Welcome and thanks for joining us. My guests today are Sean Applegate. He's the Chief Technology Officer at Swish Data, and Marlon McFate, the Public Sector Chief Technology Officer at Riverbed Technologies. Good to have you both with us today. And let's get right into it. Our topic is the wide area network, something that is necessary for the operation of pretty much every federal agency. And there's a lot of modernization that has to happen for these networks. Let's begin by kind of a state of the networks as they stand now. What do you see across federal networks, federal agencies when looking at their WAN strategies at the moment? Marlon, why don't we start with you?
Well, I would actually start with maybe even a little bit earlier than that. So, even before COVID-19, things we're going through these days, agencies for a while have been battling environments that have been becoming more and more complicated. It's an oversimplification, but at one point in time, it was more straightforward. Agencies knew where their applications were, they knew where their end users were, and for the most part, connectivity point A to point B was a private network. Complexity back then was really measured more in scale in these environments, and rationalization was a little bit more straightforward process, right? In today's world, though, even before COVID-19, there have been adding more users, more devices. Applications can live in so many different places and be deployed in so many different models. They could be in the data center, a public or a private cloud, hybrid design, software as a service. Office 365 is huge within the government customers right now. So you can imagine connecting all these is more complicated, and the straightforward networking of the past has turned more into a spider web, right, of different network connections and different network links. So using traditional networking technologies to accomplish this has been very complicated and ends up creating a fragile, meaning very small changes in one area can create very large unforeseen problems in other areas. And because of this networks not being agile, they really can't pivot when needed. And fast forwarding today with COVID-19, really what it's doing is uncovering the fragility, if you will, the non-agile characteristics. So for example, agencies want to know, how do I increase capacity quickly or get more utilization out of my existing links? Agencies are going from 30–40% of their internet-bound traffic, that was outbound traffic, and having strict security policies about who, what, and where that traffic can go, to almost, in some instances, 100% of the traffic coming in from the internet. So it really ends up being this 180-degree flip. The internet's, by and large, become, a part of the agency's wide area network. So agencies that built their networks and security to accommodate end users being at their desk are now trying to accomplish, entirely different paths between end user and apps. They want to know, how do I accommodate these new paths and need for revised security rules and the need for more capacity? These changes and pivots, though, need to be properly accommodated shifts like the one presented by COVID-19, which is huge. And in networks built on traditional networking technologies, agencies would take, weeks, if not months, to make decisions, to make changes to accommodate this. We need to move to a different paradigm, if you will.
Yeah, Sean, it sounds as if the evolution from the 3270 days and the X25 days to the IP days have brought a lot of capability, but also a lot of really tough complexity and almost a rigidness to it.
It's certainly the case, Tom. Often what we see, clients are running expensive private wide area networks today. In many cases, they're trying to cost optimize those as the traffic patterns have shifted. And so Office applications like Office 365, Salesforce, ServiceNow, or even applications like Zoom or WebEx are changing the behavior of users and their capabilities. But that also means typically at least half of the traffic we see in most customers' networks in the federal environment is going to the internet. And if they can use internet for transport as we move to TIC 3.0 architectures in the coming years, they can greatly reduce their cost, increase their capacity, and ultimately improve the performance for the users in the mission.
All right, so then I guess the question becomes, what does the good to-be state look like if they were to do another round of digital modernization and trying to get to something that is controllable and agile and not so hidebound, as Marlon put it? What does that look like?
It looks like a network where we're actually focusing more on a great end user experience, where today what we're doing is focusing on just deploying, managing, and maintaining, and trying to figure out how to construct this very complicated network. What I would say, if I was saying what would be the best end state would be networks that are self-healing, intelligent network fabric, as opposed to the traditional approaches that we've been taking. I mean, if you take a look at other areas of technology, just say, for example, applications, over a period of time, I mean, now we've got to the point where we can scale out, we can scale up, they dynamically adjust for capacity, they automatically respond to failure. You can even rebuild corrupt or lost data. So the flexibility, the resilience, and the agility of these things have increased. This is something that really hasn't happened within our networking technologies or utilizing traditional networking technologies. The reason is you can't have some of these characteristics in a traditional network because it lacks some context. In an application with these capabilities, there has to be a control element with an understanding of app context as a whole, with an understanding of the intent in that context. This is why it can make decisions it can make those decisions such as scaling and recovery. Traditional networks are individual pieces configured to work with their neighbors, but there's really no control aspect or context, no understanding of the intent or purpose outside of, basically the network team's collective brains. So to accomplish the desired flexibility and resilience, agility and performance, we need a control that has the full context. We can only accomplish that in a software-defined network.
So software-defined, sure. Sean, and how do you get there, I guess, or software definition can give you all of these qualities, resiliency, and the capacity to be aware and almost understand the user's intent, it sounds like.
That's certainly the case, and software-defined is the key statement here. In many cases in the past, devices have been managed at a device level by a small army of CCIEs in many cases that are really capable engineers. But today with software-defined networking, you really can implement and integrate a lot of the policy centrally with intent-based policies, distribute that to your software-defined edge services at a remote site, for example, or a branch, and dynamically change the nature of your wide area network or your security posture in a branch very dynamically. And so as your networks need to change with the mission or the users that are there or your new application architectures, you can do that and roll that out, and typically do it centrally with a controller, very scalable. And the focus is very much on a balance of both performance and security. So in today's federal networks where TIC 3.0 is changing architectures for direct to internet connectivity to get the applications like Office 365, we can pull that off very seamlessly.
All right, that's a good place to take a break. I'm your moderator, Tom Temin. This discussion is Digital Transformation Depends on Infrastructure Modernization, sponsored by Swish Data and Riverbed Technologies here on Federal News Network.